Chapter 7. Run analysis for an ASCII Output Report. The drainage network is defined and ready to run an analysis for a storm event. This chapter describes how to specify options to be used in the analysis and how to run the analysis. The objectives in this chapter are as follows: set up analysis for a rational method, check analysis options, specify the IDF curves, running an analysis, and typical errors to resolve. Before beginning this chapter, let's run our chapter setup for our data set. Browse to the Chapter 7 22049555201.exe file. Double-click on that file. Browse to your C drive and select Civil 3D Projects. Click OK and then click Unzip. This will overwrite any existing files in that project. Click OK and then close. Next, double-click the icon on your desktop for Autodesk Storm and Sanitary Sewer Analysis. Before we begin the exercises, to perform an analysis, the command is located in two different areas. You can go to the Analysis pull-down menu, and you have Analysis Options, and you have the option to perform an analysis, or you can check on the Perform Analysis icon. Before the software begins the simulation, the built-in model checker reviews the defined input data for any omissions or potential problems within the model. If it encounters an error with the input data, it will explain what is wrong and how to correct it. The model checker can be thought of as an expert modeler, pointing out any errors contained within the model. Exercise 7.1. Set up an analysis. Set up the hydrology method and the project options. After starting SSA, let's open our project file. Go to the File pull-down menu, choose Open, go to your Civil 3D Projects, select 22049555201, go to the Drainage folder, click on SSA Project, and then choose the proposed drainage-sr61.spf file, and then click Open. Don't worry if you get a message about finding the background drawing. Just click No for now. Next, double-click the project options under Project Data. Set the hydrology method to rational. Next, set the minimum allowable TOC to 10 minutes. And then click OK. When the rational method is selected in the project options, the data tree displays subbasins and IDF curve nodes under the hydrology branch. Now let's check the analysis options. Double-click the analysis options under the project data in the data tree to open the analysis options dialog box. On the General tab, check your date areas and make sure that you have 1 day for the analysis duration. And then click OK. Next, check the Storm Selection tab to make sure you have specified single storm analysis and then use the return period to 3 years. If you went ahead and clicked OK to close the analysis dialog box, go ahead and double-check or double-click on the analysis options again to bring it back up. And then select the Storm Selection tab. Here, make sure that single storm analysis is selected, and then for use return period, click on the down arrow and choose 3 years. and then click OK. Specifying the IDF curves in the project. The rational method uses IDF curve data instead of rain gauge data. The FDOT Civil 3D State Kit provides IDF curve files in an SSA compatible format, which can be found in the following folder. Go to your C drive, go to your FDOT Civil 3D installation folder, select Data, select SSA, select IDF curve. The IDF curve data files are organized by zones. The FDOT Drainage Manual, Figure B1, shows the IDF curve zones on a map of Florida, such as the one displayed here. The map shows our project in Wakulla County is located in Zone 2. Back in SSA, double-click the IDF curves under the project data in the data tree to open up the IDF curves dialog box. Click the Load button in the upper right corner of this dialog box. Using the Load IDF Curve dialog, browse to the folder on your C drive to your Civil 3D installation directory. Once again, choose the Data folder, choose SSA, choose IDF Curve, and here we're going to select the file FL IDF Zone 2. Next, click Open. This will return you back to the IDF Curves dialog box. Change the ID to IDF-Zone 2. Set the period to 3 years. Leave all the other settings as shown, and then click Close button in the lower right hand corner of the dialog box. Exercise 7.2. Run the analysis. From the standard toolbar, select the Perform Analysis command. If there are errors in the Perform Analysis dialog box, the analysis status will display a message. Analysis was unsuccessful. Click OK and the ASCII Output Report tabs display. Here we have an error 601. Inlet S11 has invalid bypass link at line 97. The bypass link entry defines the ID of the link that receives any flow that bypasses the storm drain inlet. If the inlet location is defined as located on sag, then this entry is grayed out, since there is no bypass link for sag inlets. The provided drop-down list provides a listing of links, such as channels, pipes, pumps, orifices, weirs, or outlets, allowing you to select the bypass link. Click on the Plan View tab to return back to your drawing. Locate S1 and double-click on S1 to open the Inlets dialog box. The bypass link is not assigned. Set the roadway gutter bypass link to L bypass-S-1. And then click Close. Rerun the analysis. If there are errors in the Perform Analysis dialog, the analysis status will display a message about the analysis was successful. Click OK and the ASCII Output Report tab is displayed. This time we have another error, error 600. Error 600 on grade inlet S12 does not have two outlet links. At least one stormwater sewer pipe and a bypass gutter must be defined. Once again, click on the Plan View tab. Locate S12 Inlet. Double-click on S12 to open the Inlets dialog box. The inlet location shows on grade. S12 is a sag inlet. Sag inlets don't require two outlets, as indicated by error 600. The inlet location drop-down list is grayed out. To correct this problem, you must change the inlet manufacturer. Choose FHWA HEC-22 generic from the inlet dialog. Then you can set the inlet location to on sag. Click Close on the Inlets dialog box. Once again, rerun the analysis from the standard toolbar. Select Perform Analysis command. If there are errors, the Perform Analysis dialog, the analysis status will display a message, Analysis was unsuccessful. Again, click OK on the ASCII Output Report tab. Click the Error Messages link in the Bookmarks panel to navigate to the bottom of the report. Here you have Error 131. Error 131. The following links form cyclic loops in the drainage system. The steady and kinematic wave flow routing methods cannot be applied to systems where a cyclic loop exists. For example, a directed path along a set of links that begins and ends at the same node. The same is true for hydrodynamic routing when water quality analysis is performed. So in this case, the pavement gutter is bypassing S3 and flowing toward S2, which is a sag inlet, but the pipe connected to S2 flows to S3. The design is correct, but the internal logic in SSA views the bypass link to be pointing to an upstream node, which it deems invalid. Ultimately, the bypass flow from S3 will go downstream to S13, and we must configure the bypass link for S3 to agree with this logic. Once again, click on the Plan View tab. Locate L pipe-2. It's between S3 and S2 structures. Select L pipe-2 and then right-click to display the pop-up menu. Select the Come From and To command. The Connect From To box opens and provides instructions on how to use the command. Click OK. Click the S3 node first, then click the S13 node. The bypass link is now hydraulically connecting the correct inlets, but the vertices need to be adjusted to clean up the display. Right-click L pipe-2 to display the pop-up menu and choose Edit Vertices. A black node appears at the current vertex. A white node appears at all other vertices. Click the white vertex near S2 and drag it towards S13 and place the vertex so the bypass geometry resembles other bypass links, and then press Escape to finish the command. Rename the bypass link L-pipe-2 to L-pipe-17. Do this by double-clicking on the pipe and then changing the link ID name. And then click the Close button. Since you renamed the bypass link, the previous name is still assigned to S3. Double-click the S3 node to open the Inlets dialog box. Click the Roadway Gutter Bypass link drop-down list. And then select L-pipe 17. And then click Close. You are now finished the analysis in exercise 7.3. Go to the File pull-down menu and choose Save. The next section is typical errors to resolve, such as add missing bypass links, correcting flow directional errors, and correcting adverse slopes. An ASCII output report is available after each analysis as shown in the following figure. Select Output ASCII Output Report or click the ASCII Output Report icon from the Output toolbar to view the report of the analysis model run. The ASCII Output Report will include an error statement, code, and description of the problem encountered. For example, error 138-June 32 had an initial depth greater than the maximum depth. Add missing bypass links. This is an example where I intentionally deleted the bypass link, then ran the analysis to generate the error. This example has no steps for the user to perform. It is intended to illustrate a situation where you will encounter and need to be aware of this remedy. When you get a message, analysis was unsuccessful, and then click OK to review the output report displayed on the ASCII Output Report tab. The error shown above indicates the bypass link specified for the inlet S1 is not valid. To troubleshoot this error, pan and zoom to inlet S1 on the Plan View tab. Pipe 1 connects S1 to S16, but there is no bypass link to connect S1 to S2. You have an example in a previous section showing you how to create a bypass link. Here is another report showing a more verbose explanation of error 600. Note, error 600. On grade inlet S-208 does not have two outlet links. At least one stormwater sewer pipe and one gutter bypass link must be defined. It's easier to view the errors within the ASCII output report and understand what needs to be done next. In this case, we need to draw a bypass link and connect it to the upstream inlet. Correcting errors is an iterative process, but produces the necessary configuration to complete the analysis without errors. Correcting flow direction errors. Swap the upstream and downstream nodes to correct flow direction errors. Correcting adverse slopes. The conveyance links dialog shows the inlet invert elevation at 28.7 or 28.87. In this example, I edited the invert elevation to lower it below the outlet invert elevation, now at 25.87. Surcharged pipes and oscillations. If the upstream end of the pipe surcharges, then a head adjustment is performed by the routing engine at the upstream connecting node. Because this head adjustment is an approximation, the computed head at the upstream node can sometimes have a tendency to bounce up and down or oscillate when the pipe first surcharges. This bouncing can sometimes cause the analysis results to become unstable. Therefore, a transition function is automatically used to smooth the changeover of head computations. If you find that the oscillation continues at the upstream node while the connected downstream pipe is surcharged, then a defined ponded area at the downstream connected node. This can sometimes eliminate the oscillation at the upstream node and produce a more stable model. Exercise 7.3. Rerun Analysis. From the standard toolbar, click the Perform Analysis command. If there are no errors, the green progress bar appears at the Perform Analysis dialog. When the analysis is complete, the analysis status will display Analysis Successful message. Click the checkbox Save Analysis Results. Browse to the folder C Civil 3D Projects 22049555201 Drainage SSA by clicking the ellipsis button. Keep the default name and click Save button to return to the Perform Analysis dialog. To review the solution file, click the File pull-down menu and select the Open Results command. Then click the Open button. The Output Report on the ASCII Output Report tab displays the contents of the .sos file. The bookmarks on the left provide a convenient way to navigate to your area of interest within the report. Note, if the ASCII Output Report tab does not display from the Output toolbar, click the ASCII Analysis Report command. Click the File drop-down menu and select Save As. Save the file using the following path name: Proposed Drainage SR61 Analysis. And click Save, and then close out of SSA.